Welcome to Learning Module 5B, Capacity Measures and Decision Tools. The quote, alleged impossibilities are opportunities for our capacities to be stretched. Well, sometimes we need to stretch our capacities personally. I really like that quote. But sometimes we need to stretch the capacities of the systems we work in as well. And those are also opportunities. Let's take a look at some of the tools, how we can measure and make sense out of capacity opportunities. So for this section, 5B, we want to learn and be able to explain how firms measure capacity. We'll look at one technique of that and calculate the difference between theoretical and rated capacity. You should know the difference technically and also be able to calculate it. Use fixed and variable cost data to calculate the indifference point between two capacity alternatives. And in fact, we will use fixed and variable cost data in a number of the models. So make sure that you understand fixed and variable costs. I'll give you a brief explanation. If you're not clear on them, call me, Google it, do whatever you need to. They're not terribly hard to grasp, but if you're not sure about it, a lot of this will not make as much sense as it should. We're going to use total cost analysis to explain how fixed and variable cost actually help us make sense of capacity decisions and to understand the different costs at different volumes. And we will apply what's called expected value analytical tools for choosing between capacity alternative scenarios. And so we'll put some likelihood, some probabilities behind several different scenarios, and that'll allow us to push out the value of those scenarios and the likelihood of those scenarios and make a better informed decision out of an ambiguous situation. Finally, well, not quite finally, we'll look at the decision tree. And the decision tree is really a graphic representation that can help, again, to understand in a complex situation, and decision trees can become very complex, and the more complicated, probably the more helpful they are to make sense out of, why are we building that plant over there? Wait a minute, it didn't feel right to me. Well, let's go back and look at this model that we developed that helped us decide and see if we think we built it properly. Then finally, last but not least, we're going to understand and calculate break-even point. Fairly simple, nice, easy formula, and that lets us know, where's the point that we've got to get to here in the volume to have this be a good decision to make this particular capacity investment. So let's take a look. So under measures of capacity, we're going to use two simple measures. One is theoretical capacity and one is rated capacity. And it's important to know the difference between the two. It's very logical and intuitive once you think through the definitions. So theoretical capacity is the maximum output capability, allowing for no adjustments for preventative maintenance, unplanned downtime, work breaks, sick leave, whatever you want to call it, all the reasons that systems and people don't work at 100% all the time. So theoretical capacity is what's possible in the short term. We can do it. We can't sustain it in the long haul. Okay? Rated capacity is what we believe we can sustain in the long haul. So in a manufacturing plant environment, that would mean building in worker breaks, building in time for planned maintenance, building in maybe even time for unplanned maintenance, right? If we have it as a recurring event. So whatever downtime we expect, inefficiencies and downtimes in the process, we would build those into the rated capacity. When we look at rated capacity here in the course, we're going to keep it real simple, but it's important as a concept that you understand that this is why companies say we want to run at 85% of capacity. Our goal is to be at 85% of capacity or 90% of capacity or 80% of capacity. And you say, why is that? Why isn't the goal 100%? Well, because no system that's realistic in most environments can run at its theoretical 100% capacity. Okay, so let's take a look. So here's an example. to understand rated capacity. We have an injection molding machine. It's a machine that makes injection molded plastics. Do I have one here? This could have been. Hey, how about that? Number one dad. Check that bad boy out. That could have been an injection mold. In fact, it probably is. Okay, so anyway, when we make plastic parts, one very common form is injection molding. We melt the plastic. It shoots through a piece of capital equipment at a certain pressure into a custom die mold, a mold that's the right shape so that the part can pop out. And we can use different molds with the same machine. We can change over and use that piece of capital, that injection molding machine, to make different parts because of the dies. So if the machine has a theoretical capacity of 100 parts per minute, and during every 10-hour shift, it operates continuously, but is shut down once for 60 minutes for cleaning, inspection, and lubrication, what is its rated capacity per minute? How would we find that? Think about it for a second, right? What is our total time that we've got? Well, we've got a 10-hour shift, right? And we're going to have 60 minutes of that 10 hours down. So 60 minutes out of 600, right? Is 10%. Let's take a look at how we could calculate it. Remember that rated capacity equals long-term expected output. So we're going to have to take that cleaning, inspection, and lubrication into account for our rated capacity. We expect the line to go down for maintenance 1 of 10 hours worked. The total time, 10 hours times 60 minutes is 600 minutes, minus the 60 minutes of downtime is 540 hours or minutes of runtime per 10-hour shift. So 540 of runtime divided by the total is 0.9 or 90%. Our rated capacity of 100 parts per minute, our rated capacity equals the theoretical capacity of 100 parts per minute times 0.9 or 90%, 90 parts per minute. Fairly simple example. Make sure you know how to do those for the exam. We will have almost certainly one question where you need to look at it, read into it, and think, what's the theoretical? What's my downtime? How do I come up with a ratio and apply it and come up with the right answer here? What is the theoretical capacity per minute? Well, that's the 100, right? We already told you at the top. So make sure you can differentiate between the two. And that can be sustained for brief periods of time. One of the easy ways to remember. It's sustainable briefly. Okay, so let's look at cost here for a moment. Some students will have already had financial or managerial accounting or might work in accounting and internships and so forth and could be very already familiar with this. So sorry, but you're going to hear it again if you already know it. It's very important in this module and in others later in the course to understand fixed costs and variable costs. Once you get them calibrated in your mind, you'll always remember it and you can apply them to a number of things in life and in business. So fixed costs, they are the expenses an organization incurs regardless of the level of business activity. Now I want you to think in your mind, well, what expenses do we regard? What would be some examples of that? Well, we have to pay the rent for our business, whether we produce or sell a single unit, right? We've got some staff in the front, some salaried staff. That is more or less a fixed cost. You could say, well, but what if we lay some off, then it's variable and so forth. But you consider, we won't get into the whole mixed cost, which is a hybrid between variable and fixed in this course. So let's generally say that fixed costs are all those things that say stable across a month's worth of business, regardless of the amount of business we incur, how much we build and sell for that month. Those costs are going to hold stable. The variable costs are the costs that will go up and down directly with the volume of business. What are some examples of variable cost? The materials that we put into our product, if we're in a manufacturing company, would be variable costs. Every time that we build this nice little coaster, that I've had for over 20 years. That nice little coaster, every time we build one, we have to buy some resin so that we can melt it down and turn it into that shape. Every time we do it, we will incur that variable cost. All right, and some business models would allow labor to be a variable cost. If we don't hold the labor stable, regardless of our business volume, if we notch it up and notch it down, then labor becomes a variable cost. If we're in a power-intensive, a utility-intensive business like making aluminum, requires a ton of electricity, we're going to have a variable cost for our electricity because we'll incur hardly any just to keep the LED lights running in the office. And when we're manufacturing, we're going to be incurring a lot of cost for that utility. So remember that fixed costs stay the same regardless of business volume. Variable costs move with the business volume. Okay, and we will apply that in a few different ways during this session. So when we think about capacity, there's a number of ways that we can try to take decisions about which business option should we choose here. And this is a really nice option because it gives 3 different examples that have a big difference in the fixed and the variable cost that pretty much any of us could understand. And it'll show us why at different business volumes, one alternative is superior to another alternative. So the indifference point, the first thing we're going to do is understand the indifference point. And that means if we looked at 2 of these options, common carrier, contract carrier, leasing, if we picked any 2 of those and we wanted to know where does it not matter? Where are the costs the same? Meaning at what quantity are the costs identical? This is how we would do it. So indifference point, the purpose is to calculate the volume of sales in units for which there is economic indifference. Okay. Is positive, negative, negative, positive. I could have worded that differently. But anyway, for where there is economic indifference between the 2 alternatives. Okay, so the indifference point. Question, at what volume does the total cost of the common carrier option we see here equal the total cost of the contract carrier option? That's what we're solving for. So to find the indifference point, which is basically the output level at which the 2 capacity alternatives generate equal cost, this is what we do. We look at the fixed cost and the variable cost for each option. Now I've added an FC and a VC next to each of those, and you'll see up in the little graph, you'll see them. So here's common carrier, 0 fixed cost. We just call in the trucks as we need them. There is no fixed cost involved, and we pay $750 in shipment cost every time that we call that truck in and have it delivered to this point, whatever this point is. For a contract carrier, we would have a long-term contract, which gives us a lower per unit price. See, the $750 goes down to $300. So $300 per unit, but every month we need to pay that contract carrier $5,000 regardless of shipping volume. So we've taken on a fixed cost and we've lowered our variable cost. So let's just look at those 2 options and find the indifference point. Cost of the contract carrier, $0 fixed, $750 per shipment, X. X represents the shipment. Cost of contract carrier, $5,000 per month, fixed cost, plus $300 times the volume of shipments as a variable cost. The formula is to zero out the lower of the fixed and variable costs on each side and then divide to find the quantity. So for fixed cost, we would take 5,000 minus 0, 5,000 minus 0, all right, which equals 5,000. And for the variable cost, we would take $750 minus the 300, which is 450. 750 minus 300 is the 450. And then we could do our calculation. So 5,000 divided by 450 equals 11.11, or 11 shipments to round it. So at 11 shipments, we would almost be to our indifference point, 11.11. We don't have 0.11 of a shipment, so we'd round it to 11. Let's look at one more. We'll do this one a little bit quicker because you've already got the conceptual stuff. So what if we wanted to compare the contract carrier and leasing? Okay, so our fixed cost for leasing is very high. We're going to lease a vehicle now. We're going to lease a vehicle. We'll have access to that vehicle all we want, and all we need to pay in variable cost is our fuel, our maintenance, and our driver's salary, right? So it's a very, very low cost on the variable side, but fixed takes a big bite. Where's the crossover point? Cost of the contract carrier, $5,000 and $300, $21,000 for the leasing fixed and $50 variable. Let's zero it out. So the fixed cost, $21,000 minus $5,000 is $16,000. Variable cost, $300 minus the $50 is $250. X, the quantity, equals 16,000 divided by the 250, which is 64 shipments in difference point. So at 64 shipments, our cost is equal between these two. Why does it matter? Because if we, of course we want to achieve as much profit as we can as a business. And by seeing this, we can say, okay, maybe we're just starting our company. And we say, well, you know what? We're going to start out with a common carrier, and we start to see some traction. We'll make a contract with them. And when we get up to 11 shipments, we know that beyond that, we will have lower cost by having this contract in place. From 11 and above, contract is superior to common. And the opposite is true below, that this is superior economically for us to just pay the variable cost until we get to 11. Leasing kicks in at 64. So as we grow our business, as we become more successful, and we get up into the 50, 60 shipment a month range, we'll start to say, wait a minute, remember looking into that leasing. How confident are we that our business is going to continue to grow and succeed? Do we feel stability? Do we feel like we're on a trajectory here with a growth trend that's going to continue? Because it's going to save us money if we go and lease a truck pretty soon. So we hopefully would have our ear to the ground. We'd be thinking of this and knowledgeable of it before we started incurring extra cost. And we would have the option then to take a fairly informed decision at a point to say, it's time to go lease a truck. Should we do it or not? Right? We know economically where the indifference point is. How confident are we? Let's roll. Okay, so understanding cost and volume, this is just a way to maybe get a good feel for a simple model of applying variable cost and fixed cost to see in an office environment what would be our cost structure per unit and per month if we had this copy machine. All right, so the Shelley Group has leased a new copier that costs $700 per month, plus 10 cents per copy. What is the total cost if Shelley makes 5,000 copies per month, and if it makes 10,000 copies per month? What is the per copy cost of the 5,000 and 10,000 copies? So what's our total cost per month, and what is our per copy cost? Well, all we need to do, uncovered the answer there, is look at our fixed cost, and then add to that the variable cost times the volume. It couldn't be simpler, right? So 700 plus 5,000 times, excuse me, there's my calculator. There it is. So the calculation would be simply 10 cents times 5,000, which is 500. Or no, it's 50, right? Yeah. And no, it's 500. Okay. And that'd be total cost of $12,000 per month, 700 plus 500. Our per copy cost is taking the 5,000 copies and dividing them into the 12,000. So 12,000 divided by 5,000 is 24 cents per copy if we copy 5,000 per month. The 10,000 level volume would still take the $700 fixed cost, but instead of the 500 that we had here in variable, we'll have 1,000 variable. So 1,000 times 10 cents per copy, or 10,000 times 10 cents per copy is 1,000. So we've got 700 in fixed cost plus 1,000 in variable cost, 1,700 total cost per month. The cost per copy is 17 cents. So, important aha moment for those of you that are already doing this in your financial managerial accounting. I'm sure it's probably going a little slow for you, but I want to make sure that everybody understands that what's going on here in this cost per copy, all right? Why is it lower? Very simple. Many of you will intuitively know what it is. Our 700 doesn't change, but we allocate that 700 across a greater number, a greater volume. So this goes back to the concept that when we have equipment and we utilize it, that our cost structure will basically go down. We want to utilize our assets in general. We don't want to have a significant amount of excess capacity because we're paying for the capacity. You can remember back in Lecture 5A where we looked at the trade-off between excess capacity and insufficient capacity. Well, this copy machine has more capacity, and when we use it, our cost structure goes down. Okay, so Ellison Seafood, they ship fresh seafood to customers in a nearby city, and the logistics manager has these three options that we've looked at a few moments ago. We're going to develop this another step in an expected value model. So we've got the common carrier, the contract carrier, and the leasing our own refrigerated trucks. We've talked about the indifference point. We've calculated the indifference point. So we know that at 11 shipments per month, it starts to become more beneficial to move into the contract carrier. We know that at 64 shipments per month, it starts moving into positive zone economically with leasing, with having a high fixed and a very low variable cost. Here is a graph, which basically is a nice, simple way to represent those curves, those lines, those trajectories. So the common carrier, with its very, very zero fixed cost, but its high variable cost, becomes expensive in our total shipping cost as our volumes go up. It becomes uncompetitive here at 11 shipments, where we calculated the indifference point, because contract starts to become more attractive. Contract can ride the wave until we get to that 64 shipments per month, where leasing becomes more attractive and stays on a nice trajectory till infinity, right? Because these lines don't turn around unless we change the model. The lines are what they are. So there's a nice, easy way to see those three alternatives. The total cost per shipment of the three alternatives we can calculate as well. So we see the opposite, right? Where common, even though it's flat, $750 per shipment, it never changes. It was our best option at low volume, $750 per shipment. And contract was higher, but it crosses over in its cost per shipment at this 11 shipment zone. And lease was astronomical at low volumes. We'd have this $21,000 we're incurring as overhead and trying to amortize that. I mean, that would be, for one shipment, we'd have $21,050, right? We'd be way off the map here if we had one shipment. We'd be up at $21,050 for one. So it's kind of a hockey stick. But once it crosses over here, never shall we return to the other zone. So there's a reason to make those capacity commitments at the right time, in the right fashion, so that they make sense. So how would we make a decision then? If we look at expected value, the thought is that we say, well, you know, we've got 15 shipments maybe in one scenario, which we would say low demand. So for some reason, we have a lot of uncertainty about we're not on a straight trajectory of growth, right? We've got competitors, we're building our business, things go right, things go wrong, we're learning, and we don't feel real confident about how fast we're going to get to a certain place. But sales has thought this through, the management team's talked it through, and we've said, well, let's create three scenarios. In one, we only get to 15 shipments and we stay there in that what we'll call low demand for a fairly long period of time. Okay, and if we get to 15 shipments, that would favor the contract carrier. So that's scenario 1. Scenario 2, if we get to 40 shipments and stay there for a long time, we'll call it medium demand. That would still favor the contract carrier. If we get to 75 shipments and we can stay there for a long period of time, then we definitely would favor the leasing overall option. Okay? So what can we do with those probabilities is reach into this expected value where we can model all 3 of those with the probabilities and the cost structure and hopefully make a good decision. Where, we're kind of struggling with if this, then we know what to do. If this, we know what to do. And if that, we know what to do. But we don't know which of them, of course, is occurring, or we wouldn't even bother modeling the whole thing. But we've set some probabilities, and we've discussed with the management team some percentages that for each of these 3 scenarios. So we set those probabilities, and this is kind of the way it would shape up, right? So low demand, medium demand, high demand. We come up with 3 different numbers. They're a little bit different than the one I showed you a minute ago, but 30, 50, and 80 shipments per year. Okay, per year, not per month. That's fine. 30, 50, and 80 per year. And low demand, 25% probability. This is a key point, this 25%. Medium demand, 60% probability. High demand, 15%, a very low probability. It's out there, but it's a low probability. These must equal 100% or the model doesn't work. All right, so we got to have 100% probability overall. And let's look at how we could turn that into a formula now. So we apply the total cost equation to the demand levels for contracting equation, 5,000 plus 300x. Okay, so for low demand, we have 5,000 plus 300 at 30 shipments, and that's $14,000. Okay, and for medium demand, we have 5,000 plus 300 times 50 shipments is $20,000, so we're putting a value to it. And at high demand, we have 5,000 fixed costs plus 300 times 80 shipments, which is $29,000. We can calculate the expected cost of the contract and the common and the lease using that methodology, okay? And we would add those up based on these percentages, all right? So here's how we calculated the contracting equation, right? It's an example, the contract, 5,000 plus 300. We would do the same for the common and the lease. So we do all 3 of them like we did here, and then we'd take those numbers, the 14, 20, and the 29, and we would drop those into their probabilities of 25%, 60%, and 15% to basically equalize them across the 100%, and we'd come up with an expected cost of $19,850. Very important to remember now that we're applying these probabilities. If we've been careless in applying these probabilities, then we shouldn't bother doing this exercise because we're misleading ourselves that we've actually created something useful. If we have created these probabilities with some intelligence and they're meaningful, no forecast is right, every forecast is wrong, it's part of the business, but forecasts can be fairly reasonably predictive if we're careful and use due diligence. Okay, so we'd have $19,850 as our estimated probable cost of contract. Depending on which scenario of demand actually firms up, we'll know our real cost. We're saying that probable cost because we're blending the 3 probable models. For common, we would do the same thing we did up here with the 0 fixed and the 750 volume to reach 3 numbers right here, which are 22,000, 37,000, and 60,000. And we would multiply those again times those probabilities, 25, 60, 15. The same factors of probability come down each of these so that we can then see the total cost if we go with common. Now you'll remember, this will make sense to you. It's not mumbo jumbo. you'll remember that it was fairly likely that we would have the contract option, right? That we would have a scenario that favored contract. Remember what the volumes were here? 50 shipments. And we know that favors contract because we did the crossover point earlier. So when we look at this, we see $37,125 under the common because we're expecting in our volumes to greatly exceed that 11 shipment crossover point. So think about it. It makes sense. It makes absolute sense that this should be expected to be the highest cost model if our three scenarios are 30 shipments, 50 shipments, and 80 shipments, because none of those are in the wheelhouse where common was the most attractive, which was under 11. Okay, moving on. For the lease, we would do the same calculations up here and extend those across, right, across those volumes, and we would find 22,000, 23,000, and 25,000, okay, in those different wheelhouses, in those different demand levels, and we would apply the probabilities to those as well, right, which is diluting each number down into 100% total, and we would see 23,475. What does this tell us? If we were trying to make a decision and we feel we've got some ambiguous information, we could go in then and say to the management team, look, I've run the probabilities we developed, and it looks like the probable least expensive model for us is going to be to contract. It's just not, we just haven't found the probability that we're going to get up into the point that the lease gets more attractive yet. This could be, we can redo this in 6 months and look again, because we all know that when lease is the right choice, we want to move into it. In the meantime, we should get a carrier in here and negotiate and get this $5,000 per month going and see if we can negotiate that down to $4,000 and get this per shipment cost as low as we can. But it looks like contract is the way to go for the phase of the business that we're in right now. We've modeled it, and we can be fairly confident of that. Okay. So for the foreseeable shipping levels, the expected shipping levels, contracting is the lowest cost. That is applying the expected value. Break-even analysis. So break-even analysis, the break-even point, the BEP, is the volume level for a business at which total revenues cover total costs. Break even. Where are we not losing but not earning? Where is that point? So the simple model for break-even point is fixed cost over our per unit selling price minus our per unit variable cost. All right, so let's take a look at how that works and how it's true. So there's you might remember we had Dirty Carl's Porta-John Fun Factory. Well, what volume does Dirty Carl need to sell each month to break even if their fixed cost is $900,000, their selling price is $400 per unit, and their variable cost per unit is $50? It's real simple. Think about the formula I just gave you. Break-even point equals, well, we need to know the difference between the per unit selling price and the per unit variable cost first. So that was $400 per unit selling price and a variable cost of $50. The difference is $350. Then we just take our fixed cost and divide it by the $350, and we see that we need $25,071.42. Or if we want to completely cover it, we would round up. If we want to say we've absolutely reached or exceeded our break-even point, we'd round up to $25.72. Really doesn't make a whole lot of difference which way you round. I won't stump you on a test with rounding one of these. So there you go. Make sure you're familiar with break-even analysis. Think about the formula, and think about what's actually happening in that number. Right. What we're doing is we're taking our total fixed cost, and we're dividing it by the contribution margin that exists between our selling price and our variable cost. We're taking that contribution margin, we're spreading it across the fixed cost, and saying, how many times do we need to do that to cover our fixed cost? Very useful when we're investing. Having a break even it's simple, but it is very important to investment decisions. Small investments and large investments, very important to know when do we get back to zero and start making money again. Okay, a decision tree is really it's nearly just a graphical representation of the expected value. There's a way to basically say we make decisions along the way of a complicated decision. We make decisions along the way, and we can branch out as we make those decisions and say, okay, which way are we going to go here? And then we can extend out the value of what would come next if we went yes or no, or right or left, or A or B at that point in the tree. We can extend out further. So the more complex the decision becomes, the more helpful a decision tree, because we can look at multiple phases of the decision to get the whole entirety of it accomplished. I will not require that we calculate a decision tree in the course, but you need to know what it is, right? So we draw the tree from left to right, make our decision points and our outcome points, develop those branches, and I'll show you an example of one. I'll show you one just so you got the feel, right? So here's the transportation decision in a decision tree. So you see the contract, the common, and the lease options. You see those three options, right? And we had an expected value for each one of those options that we calculated. And then out here we've got our 25%, 60, and 15 for each of those options. The thing about the decision tree, and maybe in future classes I'll find a more complicated example, is that if we had other decisions flowing that we wanted to build into this total process, like if we wanted to say, well, if we lease, then we want to have a B, or a C type of truck, right? A low cost small truck, or a higher cost large truck, or a third option with a big highway truck with its own refrigeration equipment. We could build that into here. So we'd build it off this branch, and this branch, and say, well, actually, no, we'd only build it here, wouldn't we? We'd say it's the lease option, and it's 80 shipments, and here it comes. Which of these truck options should we take off here? So the more complex the decision becomes, the more useful decision trees are. Here's a section summary for you. So remember that firms consider rated rather than theoretical capacity as a long-term measurement of capacity. We know what we can do in short bursts, but we never gauge our outcome and commitments to customers and expectations of productivity and efficiency and so forth on theoretical capacity. We have to have a way to find what's realistic, what we can really do in the long haul, not just in short bursts. The indifference point allows firms to understand crossover for different capacity options. And I think because we walked through that same example and you saw where that indifference point kept coming in, right? And saying, oh yeah, that's right. At 11 shipments, we shift over that indifference point and it becomes better to get into a contract with a company. And then at 64, leasing is going to start making us more money. So indifference points can be very valuable, very informative in capacity. Total costs allow firms to see the impact of volume on different capacity costs. So we can look at like the cost per copy on a copy machine, or the total cost for the machine on different volumes. But we can also model different options and build in, use it with expected value and say, well, the likelihood of option A or scenario A, and the likelihood of scenario B and scenario C and scenario D are these. The cost of the different options can run this way, and the probability of the different scenarios can run this way, so that we can really come out of it and say, okay, it's still a little ambiguous, but from this analysis, it looks like we should use contract. And we'll redo this analysis as our volumes change and as our confidence changes about our volumes. or maybe just the cost of some of the options changes, right? So things are never done. But we'll take some decisions, and then when it's appropriate, in a month, in a year, in 5 years, whenever it is, we'll run numbers again. We won't rely on something that's old and dusty. The break-even point, finally, just remember that it's a very simple calculation. I'm sure it'll be on an exam and you'll have the formula there, but make sure you understand what we're really doing there. We're trying to figure out what volume do we need to get back to even, and we can make money. But are we confident that we're going to get the kind of volume we need to get our money back if we make this investment? Break-even point's a very important number. I hope you enjoyed that section, 5B, where we did some calculations and some measurements, and that concludes the lecture.